Are you recycling correctly? Hi, my name is Tommy, and I'll be taking you on my Recycle Right journey designing for public spaces. Let us look at the global picture of the current state of recycling. In 2018, China implemented Operation National Sword, which set a strict contamination limit on all foreign recyclable waste imports. This results in more projected landfills among many countries, as we continue to produce more waste than what we can recycle and recover. It has become a global crisis where the list of recycled items is shrinking. As the items are too contaminated, the foreign ban has set a new standard of recycling for many countries to tackle on their own. What about here in Singapore? Unfortunately, we have a long way to go. The sight of domestic recycling bins around the neighbourhood shows for itself on how local communities are treating them just like any other general waste bin. This resulted in only 4% of our plastic waste being recycled, less than 20% of our domestic recycling as of 2019, due to the high contamination rate. Despite the latest efforts by the National Environmental Agency with the introduction of the new recycling labels to address this problem, how does this impact us, the supposed clean and green nation? Our only remaining Semakau landfill that was projected to fill up by 2045, now shortened by a decade to 2035 due to the mounting waste issue. Government officials shared that they aim to reduce the amount of waste by 30% by 2030. This showed that strategies proposed at even a national level are not a one-stop solution in solving these sustainability issues, but a more progressive approach in allowing citizens to do their part in adopting a more sustainable lifestyle. So what exactly is recycling contamination? Here is a list of food and liquid waste items commonly thrown in recycling bins. Recyclables should be of an empty or rinsed condition to be exported. So I asked myself, how could I utilize participatory design methods to increase the success of initiatives targeted to reduce the food and liquid contamination rate at recycling points? I started off my investigation study in NUS and estimated public outreach of 50,000 students and staff. Looking into a recent case study, our very own division's recycling bin project, speed bumps, designed in 2018. The hypothesis of the project: contamination rate will reduce as speed bumps disrupt automatic behavior and provide timely prompts for people to recycle the correct items. The study was conducted at 2 locations, with treatment and control groups for a more accurate study. After multiple sessions of data collection through dumpster diving, there were 2 key findings. Users were still recycling what they perceived as acceptable quality of recyclables, yet there was a 22% reduction in plastic contamination compared to the baseline readings from the old design. The NUS recycling expert then shared that none of the plastics have been recycled for the past year due to high contamination. It was essential for me to understand the behavioral process that goes into the act of recycling to design more accurately in this space. With literature research on habit theories and expert workshop with NEA officers, I learned that the act of disposing waste or recycling becomes mindless over time. It is essential to have a supporting environment to facilitate public cleanliness or recycling. At this point, this served as guiding principles for my observation and interviews. There were 3 key areas that had potential to be improved: location, messaging, and the possibility to leverage off the takeaway culture where student population engage in fast-paced schedules that support quick decision-making habits. More survey interviews were conducted to uncover the driving factors to recycle. 2 key insights were drawn from this: participants having recycle right misconceptions, and the expressed perceived inconvenience to rinse or recycle their recyclables. I then categorized them as aspirational recyclers, those who are willing to continue to recycle based on what they thought was correct. Concurrently, I wanted to find out whether iconography or actual object images of recyclables shown on the bins had any impact with the misconception users had. Participants were tasked with a card sorting exercise focused on sorting the given waste items in a recycling scenario. They were also to think out loud through the process to share the ease and the pain points. Results showed that they were able to sort the actual images easier. In psychology and cognitive science, it is a mental concept called schema that informs the user about what to expect from a variety of experiences and situations. All of them were able to identify the images for its specific material type and visible qualities. while iconography suggested more options based on their own memory, which created more confusion during the exercise. This meant that vision saliency is important in how I design information at the recycling points. Benchmarking bin designs that presented salient messaging and intuitive high and low text solutions that facilitate clean recycling. So how might we redesign and optimize the recycling point based on the given insights? Tryouts were done in a co-working environment, with the co-location of the recycling and rinsing point to test the perceived inconvenience users were sharing, with iconography and actual object recycling label variations. Results remain consistent with the card sorting exercise that actual object images work better with the improvement in recyclable quality during the tryouts. This was proposed as the optimal location for future recycling points. As the sample size was still rather small in the enclosed environment from the tryouts, a more diverse audience was necessary in evaluating the intervention outcome. A compromise solution where I applied the improved labels for the current existing bins located around campus. This was to test if it was consistent with the contamination reduction. Segmenting the current label information to focus on correct recycling and actionable visuals on the bin. The incorrect item information was extracted into a large format print to be the prominent feature in drawing immediate attention to correct wrong recycling. This was tested over 2 weeks at a recycling point located near a food court, and the results were more than consistent with an increase in recycling rate and reduced contamination. A full-scale pilot test was conducted at U-Town with 9 bin locations over 2 weeks, with the new large labels to disrupt automatic behavior and provide timely information about incorrect non-recyclables. The results showed that contamination reduction was not as high as compared to the previous tryouts, but came with valuable insights on how we could improve. To further understand what the aspirational recyclers needed to help them recycle better, face-to-face surveys were conducted at the recycling points with users who used the bins. The feedback showed that there was a lack of knowledge that items containing remnant food waste needs to be rinsed, and 8 out of 10 of them did not even notice the new features. These insights showed that both the speed bumps and new label design interventions had great compatibility in addressing the contamination problem. We learned that recycling is a very specific task in this local context, and users require specific directions to perform the right task, which meant a more defensive and intuitive bin system is needed, and recycle right publicity outreach to educate the public. How might we redesign the recycling point to nudge recyclers from mindlessly trashing to mindfully recycling right? The keyword clarity came to mind when conceptualizing the bin's form through making physical mockups and sketching. I went through back and forth consultations with stakeholders with regards to implementation feasibility and maintenance considerations to refine the bin ideas. The bin concept was then refined through prototyping and testing of defensive lid iterations, with the shrinking of the bin opening for specific recyclables to go through only. Then, I followed up with a short observation study to see how users reacted to the refined bin prototype, displaying actual incorrect non-recyclables. During the study, it showed that it was able to draw immediate attention from the users, and bin security is needed to prevent users from mishandling the display. The quality of recyclables collected was inconclusive, as I had limited evaluation time due to the circuit breaker measures that were about to be put in place back then. At that point, the concept was pitched to more stakeholders. The maintenance and longevity of the bin design were key concerns that I had to address if the prototype was going to be fabricated for future mass deployment. So, I improvised and worked on the improvements by getting my family members to test out the bin prototype. My final testing was focused on the bin interaction with users for my proposed solution. And with that, I introduced to you the Recycle Right bin, designed for mindful recycling to reduce food and liquid contamination by disrupting automatic behavior with its defensive opening and providing timely display of incorrect non-recyclables to educate users what should not go together with our clean recyclables. By strategically co-locating the Recycle Right bin with facilities that promotes rinsing or emptying of recyclables, such as shopping malls and community centers. The stainless steel bin housing highlights the specific correct item and a visual representation of its recyclable quality on a semi-acrylic bin unit. The deliberate cutout from the defensive lid allows users to swing open with their clean recyclables. This reduces the contaminants from being mindlessly accumulated in the bin. The supporting message on the lid itself for users to ensure recyclables are in the right condition. With the itemization of common recycling contaminants, it has been repurposed as an educational tool for users to correct their own recycling mistakes. Then once the trash bags are full, the cleaning staff can exchange it by removing the detachable holder from the bin. In this manner, aspirational recyclers can learn and correct themselves of their recycling misconceptions. A practical way for all of us to live more sustainably, one recyclable at a time, working towards a zero-waste nation.